Hello, everybody. Hello. How is everybody doing today? All right, so we're going to pick up where we left off yesterday. So just as a reminder, oops, this is not where we left off yesterday. Sorry about that. This is where we left off yesterday. So we are looking at section 6.3, which is about the double angle and half angle identities. So we saw yesterday that there was one formula for the sine of 2a, that is 2 sine A cosine A, and we came up with 3 formulas for the cosine of 2a. So one was cosine squared A minus sine squared A, one was 1 minus 2 sine squared A, and then the third one was 2 cosine squared A minus 1. No, you didn't need to print out any new ones for today. We're just going to finish up section 6.3, and then I will get the next one posted, and we'll look at it Monday. We won't have class tomorrow. Any other questions before we get going? Okay. And we've got a formula for the tangent of 2a. That's 2 tangent A over 1 minus tangent squared A. We looked at an example. We verified an identity. Actually, we verified 2 identities. We found, well, you don't need to memorize this, but you will be able to use your notes. So you'll want to be able to access them. That makes sense? Okay. So we have a formula for sine squared A. It's equal to 1 minus the cosine of 2a over 2. And then cosine squared A is 1 plus the cosine of 2a over 2. And we've got a formula for the tangent squared of A. It's 1 minus the cosine of 2a over 1 plus the cosine of 2a. And then we get a half angle identity that the sine of A divided by 2 is plus or minus. You need to figure out which one for the particular problem. The square root of 1 minus the cosine A over 2. And then the cosine of A divided by 2 is plus or minus. You'll need to figure out depending on the problem. The square root of 1 plus the cosine of A over 2. And the tangent of A over 2 is plus or minus the square root of 1 minus the cosine of A divided by 1 plus the cosine of A. And then there are 2 other formulas as well. We have tangent of A over 2 is equal to the sine of A divided by 1 plus the cosine of A. And it's also equal to 1 minus the cosine of A divided by the sine of A. And then we were looking at this example. We found that the cosine of 5 pi over 8, we used our formula from right here. So A over 2, that's the 5 pi over 8. And then we saw then that A would be 5 pi over 4. And since 5 pi over 8 was in quadrant 2, its cosine's negative, so we use the negative rather than a plus. It's plus or minus. we use the negative, and then we have 1 plus the cosine of a, so that's 1 plus the cosine of 5 pi over 4, all over 2, and the 2 is under the square root. And then we needed to figure out what is the cosine of 5 pi over 4. And because 5 pi over 4 is in quadrant number 3, so the cosine of 5 pi over 4 is equal to minus the square root of 2 over 2. Okay, so we filled in the cosine of 5 pi over 4, that's minus the square root of 2 over 2. And then in order to subtract 1 minus the square root of 2 over 2, I needed a common denominator. And that was 2. So I changed 1 into 2 over 2. So I have 2 over 2 minus the square root of 2 over 2. And so that became, so I had 2 over 2 minus the square root of 2 over 2. And that turns into 2 minus the square root of 2. That's what I get on the top, and the bottom is still 2 because that's the common denominator. And so then when I take this and put it over the denominator 2, I end up with 2 minus the square root of 2 over 4 as my fraction. And I can go ahead and do the square root of 4. That gives me a 2 on the bottom. So I end up with minus the square root of 2 minus the square root of 2 all over 2. Are we ready for the next problem? Okay, so for the next problem, I need to figure out the sine of pi over 12. So pi over 12 is going to be in quadrant number 1, okay, because pi over 2 is the same thing as 6 pi over 12. So 1 pi over 12, since it's smaller than 6 pi over 12, it's going to be in quadrant number 1. So that tells me that the sine and the cosine will be positive because in quadrant 1, sine and cosine are positive. So I know to use the plus sign. So I'm going to use my formula for the sine of a over 2. And the sine of a over 2 is plus or minus the square root of 1 minus the cosine of a over 2. So I need to figure out what a is. So since a over 2 is pi over 12, I can go ahead and solve that equation for a. I'll multiply both sides by 2, and I get that a is 2 times pi over 12. So in other words, a is pi over 6. So pi over 12 is equal to pi over 6 divided by 2. So that's what my a is. So filling in my formula, the cosine of a, so 1 minus the cosine of pi over 6. And then the bottom of my formula is just a 2. Does that make sense so far? Okay. So I need to figure out, well, what is the cosine of pi over 6? And I can remember from my unit circle that the cosine of pi over 6 is the square root of 3 over 2. So now I've filled that in, and I want to combine the 1 minus the square root of 3 over 2, so I'll get a common denominator. That's 2 over 2 minus the square root of 3 over 2. And all of that is over 2. So again, I'll do what I did up above. I know that 2 over 2 minus the square root of 3 over 2 is equal to 2 minus the square root of 3 all over 2. So that's going to be the top of this. And so I can put it together and say this is 2 minus the square root of 3. And I have a denominator of 2, and I'm dividing by 2, so that's going to give me a 4 on the bottom. I can go ahead and do the square root on the bottom. That makes a 2 on the bottom. And on the top, I just have 2 minus the square root of 3. Are there any questions about any of that? Okay. So next, we're told that the tangent of x is equal to 3/2, and that x is an angle in the third quadrant because x is in between pi and 3 pi over 2. And we want to figure out the tangent of x over 2. And I can use any one of those 3 formulas up here. I've decided to go with the last formula, 1 minus cosine A over sine A, which you could use. How did we get a change in the denominator? Sorry about that. Well, so the last thing I did was I figured out that the square root of 4 was equal to 2. So that's what I did here. Up above, I had a fraction. I had 2 minus the square root of 3 divided by 2. And then I took that and I divided again by 2. And so when I first divide by 2 and it divide again by 2, that's how I'm going to get a 4 on the bottom. Okay? All right, so looking at our next example, I decided to use 1 minus the cosine of x over the sine of x. Oops, sine x. I don't know the cosine and I don't know the sine. So I need to figure out the sine and the cosine. However, I know the tangent's equal to 3/2. So that tells me that x can be -2 and y can be -3 because tangent is always y over x. So I'm going to go ahead and figure out what r is. And I know that x squared plus y squared equals r squared. So -2 squared plus -3 squared equals r squared. So I have 4 plus 9 equals r squared. R will always be positive, so r is the square root of 13. Now I know what r is, and remember that cosine is x over r. It's a different x. I have one x standing for the angle and the other x standing for the x coordinate, which is -2. So don't get confused between the two of those. So I end up with -2 over the square root of 13. And then for sine, I'm going to use the y value, so that'll be -3 over the square root of 13. So I have 1 minus -2 over the square root of 13. And then down here, I have -3 over the square root of 13. Does that make sense so far? Okay. So now I'm going to first find a common denominator. And notice that I'm subtracting a negative on the top. So I'm really adding. And I'm going to think of this as the square root of 13 over the square root of 13. That's my common denominator. I'm running out of space though. So let me get more space here. So the square root of 13 over the square root of 13. And since I'm subtracting a negative, I'm really adding 2 over the square root of 13. And that's the top once I get my common denominator. And then on the bottom, I still have negative 3 over the square root of 13. So on the top, I'm going to go ahead and turn it into a single fraction. I have the square root of 13 plus 2 all over the square root of 13. And then I'm dividing that by the fraction negative 3 over the square root of 13. So I'm going to go ahead down here. And so I'm taking my fraction on the top, the square root of 13 plus 2 divided by the square root of 13. And I'm taking a fraction, I'm dividing by a fraction. So I'm going to invert and multiply now. So the fraction on the bottom, when I multiply it, becomes the square root of 13 over a negative 3. My square roots of 13 will cancel out, and I end up with the square root of 13 plus 2 on top, and on the bottom, I just have a negative 3. We don't need to rationalize the square root on the bottom because it just ends up canceling out. Does that make sense? We also, another way to look at it, we have a square root 13 on the bottom right here and a square root of 13 on the bottom right here. So we could just multiply the top and bottom by the square root of 13, and that would get us over to here also. There's a couple ways that we can do that. Is that okay? Any more questions before we look at the other example? Okay. So we're going to verify that the tangent of a over 2 plus the cotangent of a over 2 is equal to 2 times the cosecant of a. I'm going to use the same formula that I used up here. So when I did the tangent of x over 2, I have 1 minus the cosine of x over the sine of x. I'm going to use that. So right here, I get 1 minus the cosine of a on the top, and I have the sine of a on the bottom. And cotangent of a over 2, well, that's 1 over the tangent of a over 2. Does that make sense? Cotangent is always 1 over tangent. So I'm going to leave this first one alone. I have 1 minus the cosine of a over the sine of a. And then over here, the 1 just stays 1, but the tangent of a over 2, I know that's 1 minus the cosine of a over the sine of a. So I'm going to put that fraction on the bottom. That makes sense so far? All right, so then my first fraction I'm going to leave alone. I have 1 minus the cosine of a over the sine of a. This fraction, if I take 1 and I divide by a fraction, what ends up happening is the fraction gets flipped upside down. So I have sine a on top, and I have 1 minus the cosine of a on the bottom. Does that look all right so far? Okay. Oh, you know what? I didn't mean to do exactly what I did. I'm going to come back up here. This tangent of a over 2, I changed my mind. I actually want to use my other formula because I think it's going to work out nicer. So I'm going to use this formula for my other tangent of a over 2. All right, so here, I'm going to replace this. I'm going to do, trying to replace it. sine of A on top, and 1 plus cosine A on the bottom. Okay, and so that means that I'm going to end up with sine A on the bottom here when I flip my fraction upside down. And I'm going to end up with 1 plus the cosine of A on the top. Okay, and the reason I did that is because now both of my fractions have the sine of A on the bottom. Okay, and remember, I'm trying to end up with cosecant A. And cosecant A is 1 over sine A. So it seems like a good idea to get sine A on the bottom. So I'm going to go ahead, since both of my fractions have sine A on the bottom, I can go ahead and just make a single fraction. So I have 1 minus the cosine of A plus 1 plus the cosine of A. That's what I get on the top. And on the bottom, I just have the sine of A. And you probably noticed something now that is really nice. I have a minus cosine A and I have a plus cosine A. Those are just going to cancel out. And I'm just going to end up with 2 on top and sine A on the bottom. And 2 over sine A is 2 cosecant A. Okay, so the first time I tried it, I used the same formula in both spots. Make sense? And then it didn't work out as nice. So I said, well, let's go back and try it the other way. Let's use the other formula so that both of my fractions end up with sine A on the bottom. And that's because I knew that I wanted to end up with cosecant. In order to get cosecant, I would want sine on the bottom. Okay? All right, so that is it for section 6.3. We're going to start on 6.4 on Monday. Remember, you've got homeworks on MyLab to work on. And you have, I think, 2 quizzes. I'm working on setting up another quiz for you. If anybody had any questions, please go ahead and ask or send me an email or whatever you feel most comfortable with. The first quiz is on section 5.2 and the next quiz is on section 5.3. Okay, and I hope everybody is doing well, not going too crazy with being stuck at home. I think your quiz is due at 5 p.m. if I remember correctly. Any other questions? Okay. Well, again, I hope everybody is doing well and staying safe. Please let me know if there's anything that I can help you with. All right. I enjoyed seeing everybody here today. I'll see you again on Monday. Have a good weekend.